Having come to the end of our organic chemistry course, it's a good idea to review all the synthetic routes that we have come across, including those that we met in AS. So let's start at where we finished with AS. Those were the functional groups that we'd come across then, and we of course have studied those in more detail, particularly the ketones and aldehydes, carboxylic acids, this during your second year. And we've also introduced these new topics. So acid anhydrides, hydroxynitriles, acyl halides, esters, amides, amines, and nitriles. So this was our synthetic route diagram that we completed at the end of AS, and we're now going to add to this those new functional groups that we've met during A2. So the first thing we're going to do is we're going to add in the reduction of aldehydes back to aldehydes and ketones back to alcohols, because we now know we can do that using sodium borohydride in aqueous conditions. So we know how to oxidize alcohols to aldehydes and ketones, and we can also reduce ketones and aldehydes back to alcohols. We can now begin to add in the new functional groups that we've met at A2 level. First one, of course, esters. And esters are made by refluxing alcohols and carboxylic acids together with a concentrated sulfuric acid catalyst. We can also make esters by reacting alcohols with acid anhydrides. Acyl halides, also a new group that we've met. Acyl halides can be used to make esters by reacting them with the required alcohol. And we make acyl halides by reacting them with SOCl2, and if we add water to an acyl halide, we will get back the carboxylic acid. We've also met amines. Amines are prepared by reacting an excess of ammonia in a sealed tube in ethanol with a halogenyl alkane. And we've also met nitriles. Nitriles can be turned into carboxylic acids by adding dilute HCl, and they can be made into amines by reacting them with hydrogen and a nickel catalyst. And we can turn halogenyl alkanes into nitriles by reacting them with sodium cyanide. Hydroxynitriles are produced by reacting aldehydes or ketones with NaCN under acid conditions. And we can also make amides by reacting acyl halides with ammonia. And if we choose to use an amine instead, we can also make an amide which is N-substituted. So that's a summary of the synthetic routes that we've met at A2. If you follow the link to the website, you'll be able to access a whole range of topics, videos and resources. So go to the index, which your front page will take you to, and then just click on the relevant section that you would like to study in more detail.